Hello and welcome to Dr. T's Algebra 2 class. In this video, I'll be looking at two-way tables and how to find probabilities, including conditional probabilities from those two-way tables. This first two-way table has males, females, and whether they play baseball, basketball, or football. Now, when looking at a two-way table, the totals are always on the bottom row and the rightmost column, and we're working with rows and columns. And so all of those rows and columns are going to add up from top to bottom and from left to right. Regardless of which row or column we're in, all of the numbers add up to get the sums of the columns, the rows, and final the grand total over there in the bottom right. So we've got all of the numbers set out for us. So we can start looking at probabilities. Well, if we wanted to know, for example, the probability that a randomly chosen student was male, we take the total number of males, 48, that's our numerator, and divide that by the total number of students. And conveniently, 100 total gives us an easy calculation to find percentage. So there's a 48% chance that a randomly chosen student is male. Well, how about if we wanted to know the probability that a student is both male and plays basketball? Well, that's going to be the intersection there, a male who plays basketball, 15 over 100 total students. So that's 15% of students are both male and play basketball. Well, let's take, for example, another situation where we want to know the probability that a student is female given that she plays football. And let's just assume that this is soccer, but it could be American football. Well, we know that she plays football, so we're going to look at all the students who play football. 33. That's our denominator. So of those 33, 13 are female. So there's a 13 and 33 chance that given that we know she plays football, given that upon condition that she plays football, that she is female. 13 out of 33 is the number. And then let's say we want to know the probability that a student plays basketball given that she is female. So we're going to first look at the number of females, which is 52. So that's our denominator. And of those 52, how many play basketball? 16. And we can reduce these fractions, but that is the main idea. Get another example. And so we've got people who like soccer, who like football, who like vanilla, and who like chocolate. And then again, two-way tables work two different ways. We got rows and we got columns. Adding from top to bottom and left to right. They always add up. So 18 plus 32 is 50, 18 plus 12 is 30, and so on. So just like the last example, let's say we want to know the probability that somebody likes soccer given that they like vanilla. Well, let's look at all of those who like vanilla. That's 50. So 50 is our denominator. And of those who like vanilla, 18 like soccer. And we can reduce this if we want. That's 9 out of 25. And generally speaking, a fraction is the best answer for these probability problems because we don't have to round any decimals. Sometimes we get a terminating decimal, but very often it's a non-terminating decimal, so a fraction will do. Let's just look again. Say we want to know the probability that somebody likes football. Well, that's going to be total who like football divided by or out of all of the people together. So this is the whole on the bottom, and this is the part on the top. We always want to have the whole on the bottom and the part on the top. Even when, say, for example, we say the probability that somebody likes chocolate given that they like soccer. Well, we still have whole and part, but our whole this time is a little bit less of the 72 whole given that they like soccer. So we want to take the whole now is 30. So that's our sample space, if you will. That's the total population from which we're going to say how many like chocolate? Well, 12. So of the people who like soccer, that's our condition, upon condition here. Of the people who like soccer, what's the probability that a randomly selected one will also like chocolate? Well, that's going to be 12 of those who like soccer also like chocolate. Fairly straightforward stuff. Sometimes you'll come across a 2A table that is incomplete, but taking from the rule that we're adding right to left, top to bottom, we can figure out the numbers fairly easily. So if we're adding top to bottom, that means we can subtract bottom to top, meaning that 38 minus 20 gives us this missing value. 13 plus 15 gives us this missing value. 38 and 28 is 58, 66. 66 and 40 is 106. 20 and 13 is 33. 50 minus 33 is 17. So 20, 13 is 33. Plus 10 is 43. Plus 7 is 50. That looks good. 17 and something equal 40. Well, 40 minus 17 is 23. So we're trucking along to our totals here. And then 18 and 15 gives us 18, 28, 33, 53 here, 56, and coincidentally 56 and 50 equal 106. That all checks out. It's important that you double check, again, right to left, top to bottom on all your rows and columns just to make sure that you didn't add incorrectly, because that'll mess up the probabilities. So now we can just go back to finding, say, the probability that somebody likes math given that they are a girl. So we know the person is a girl. Let's look at now, that's our whole. 50 is going to be on the bottom. And of those who are girls, 13 like math. Very straightforward stuff. How about the probability of a randomly selected student being a boy? Well, now our whole is the whole of all students, boys and girls, and however many of them like all of these different subjects together, or are enrolled in these different subjects, however, whatever the case may be. So of the students, of all the students, 106 is our whole. Our part is 56, those who are male. Once again, how about the probability of a student being a girl and in science or liking science? Well, those who are both girl and science is 17. So we're just moving over this row and this column. Where they meet is 17. And lacking any other information, we think that we can assume that we're taking this girl who likes science out of the entire population. So that's 17 over 106. How about the probability that a student likes English or is enrolled in English given that they are a boy? Well, we know that given is now our new total, so we're going to look at 56 is our total, it's our whole. And of those 56, how many like English? Well, it's going to be 18 up top. And so looking at two-way tables, these are a straightforward and fairly intuitive way to find conditional probabilities and other probabilities. If you can't remember the formulae for these different probabilities, well then, if you can make a two-way table, that might help you to figure it out. This has been Dr. T's Algebra 2. Thank you.